The National Electrical Code on EC typically requires either intermediate metal conduit, or ESER, or rigid metal conduit, or RMC, for underground electrical runs to manufactured homes. Polyvinyl chloride, or PVC, is generally not recognized for this specific application. However, using rigid PVC for the 100 amp service lateral might be acceptable, but it often necessitates installing concrete encased electrodes, or SECs, at the service equipment location. Regarding the sequence of pulling wires versus trench construction and backfilling, the generally favored and more straightforward approach involves pulling the wires into the conduit before backfilling the trench. This methodology offers several advantages. Firstly, it allows for a thorough inspection of the wires for any potential damage as they are being pulled through the conduit. Identifying and addressing any insulation abrasions or other impairments before burial can prevent future electrical faults. Secondly, pulling wires before backfilling simplifies the process of adding another wire to the circuit at a later time. With pre-existing conduit in place, adding a wire becomes a relatively simple task of pulling it through the existing raceway. In contrast, backfilling the trench before pulling wires introduces several challenges. The compacted soil surrounding the conduit can make wire pulling significantly more difficult, increasing the risk of insulation damage due to friction. Moreover, adding wires after backfilling necessitates excavating the trench again, which can be time-consuming and disruptive. It is important to note that the specific requirements and interpretations of the National Electrical Code can vary depending on the local authority having jurisdiction, OJ. It is always recommended to consult with the local AHA to ensure that the electrical installation complies with all applicable regulations and safety standards. Furthermore, careful consideration should be given to the selection of appropriate wire types and sizes for underground service applications. Aluminum conductors are commonly used for service entrance conductors, but it is essential to ensure that the chosen conductor size is sufficient to carry the intended load without exceeding its ampacity rating. The National Electrical Code provides tables that specify the allowable ampacities of various conductor types and sizes under different installation conditions. The type of insulation used on the conductors is also a critical factor. Underground service conductors should be insulated with materials that are specifically designed for direct burial applications and are resistant to moisture, chemicals, and physical damage. Additionally, proper grounding and bonding practices are essential for ensuring electrical safety and preventing equipment damage. The grounding system should be designed to provide a low impedance path for fault currents to return to the source, minimizing the risk of electric shock and facilitating the operation of overcurrent protective devices such as circuit breakers and fuses. The grounding electrode system should be installed in accordance with the National Electrical Code requirements and should include a grounding electrode conductor that is connected to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. Bonding involves connecting all metallic parts of the electrical system together to create an equipotential plane, which helps to minimize voltage differences and reduce the risk of electric shock. Bonding conductors should be sized and installed in accordance with the National Electrical Code requirements. When installing underground electrical service, it is crucial to maintain proper clearances between the conduit and other underground utilities, such as water pipes, gas lines, and communication cables. The National Electrical Code specifies minimum separation distances to prevent accidental contact between the electrical system and other utilities. Before excavating, it is essential to contact the local utility companies to locate and mark the positions of any underground utilities in the area. This will help to prevent damage to the utilities and ensure the safety of the workers. The depth of burial for underground electrical conduit is also specified by the National Electrical Code. The minimum burial depth depends on the voltage of the circuit and the type of conduit used. In general, higher voltage circuits require deeper burial depths to provide adequate protection from physical damage. The trench should be excavated to the required depth and should be wide enough to accommodate the conduit and any necessary bedding material. Bedding material, such as sand or gravel, should be placed in the bottom of the trench to provide a smooth and stable base for the conduit. After the conduit is installed, it should be backfilled with suitable material such as soil or sand. The backfill material should be compacted to prevent settling and protect the conduit from damage. The conduit should be supported at appropriate intervals to prevent sagging and maintain its alignment. The support should be made of non-metallic materials to avoid corrosion. When connecting the underground service conductors to the service equipment, it is essential to use properly rated connectors and terminals. The connectors and terminals should be suitable for use with the type of conductor being used and should be installed in accordance with the manufacturer's instructions. The connections should be tight and secure to prevent overheating and arcing. The service equipment should be installed in a location that is readily accessible and protected from the weather. The equipment should be mounted securely to a wall or other support structure and should be properly grounded and bonded. The service equipment should include a main disconnect switch that can be used to energize the entire electrical system. The main disconnect switch should be clearly labeled and readily accessible in case of emergency. Overcurrent protective devices such as circuit breakers and fuses should be installed to protect the electrical system from overloads and short circuits. The overcurrent protective devices should be sized in accordance with the National Electrical Code requirements and should be installed in a readily accessible location. All electrical work should be performed by qualified and licensed electricians who are familiar with the National Electrical Code and local electrical codes. The electrical installation should be inspected by a qualified electrical inspector to ensure that it complies with all applicable regulations and safety standards. If concrete encased electrodes are required, the installation must adhere to specific guidelines. These electrodes are typically required when using PVC conduit for the service lateral, as it provides a supplemental grounding path. The concrete encasement must be at least 2 inches thick and should fully surround the grounding electrode. The electrode itself can be a ground rod or a length of rebar, and it must be at least 8 feet long. The concrete mix used for the encasement should be a standard mix with a compressive strength of at least 2,500 pounds per square inch. The concrete encased electrode should be located as close as possible to the service equipment and should be accessible for inspection and testing. Furthermore, when working with aluminum conductors, it is crucial to use connectors and terminals that are specifically designed for use with aluminum. Aluminum is more susceptible to corrosion than copper, and using incompatible connectors can lead to corrosion and failure of the connection. The connectors should be made of aluminum or a bimetallic material that is compatible with both aluminum and copper. They should also be treated with an antioxidant compound to prevent corrosion. When tightening the connectors, it is essential to use a torque wrench to ensure that they are tightened to the manufacturer's specified torque. Over-tightening can damage the conductors or connectors, while under-tightening can result in a loose connection. In addition to the above considerations, it is also important to be aware of the potential hazards associated with working with electricity. Electrical work should only be performed by qualified and experienced individuals who are familiar with safe work practices. Before starting any electrical work, it is essential to de-energize the circuit and verify that it is de-energized using a voltage tester. Rubber gloves and other personal protective equipment should be worn to protect against electric shock. The work area should be kept clean and dry to prevent slits and falls. Finally, it is crucial to remember that the information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and a local authority having jurisdiction to ensure that the electrical installation complies with all applicable regulations and safety standards. Understanding ampacity is very important. Ampacity refers to the current carrying capacity of an electrical conductor. It is the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor's material, size, insulation type, and installation conditions. The National Electrical Code, or NEC, provides tables that list the ampacities of various conductors under different conditions. It's crucial to select conductors with adequate ampacity for the intended load to prevent overheating, insulation damage, and potential fire hazards. The NEC specifies different ampacity ratings for conductors based on their insulation type and the ambient temperature. For example, conductors with higher temperature ratings, such as those with THHN or XHHW insulation, can carry more current than conductors with lower temperature ratings, such as those with TW insulation. The NEC also provides directing factors that must be applied when conductors are installed in certain conditions, such as when they are bundled together in a conduit or when they are exposed to high ambient temperatures. Directing reduces the allowable ampacity of the conductors to account for the increased heat generated by the conductors. Proper conductor sizing is essential for ensuring the safe and reliable operation of electrical systems. Undersized conductors can overheat and cause insulation damage, while oversized conductors can be unnecessarily expensive. The NEC provides guidelines for selecting the appropriate conductor size based on the load current and the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, conductors should be sized appropriately and the length of the circuit should be kept as short as possible. Furthermore, it is essential to use proper termination methods when connecting conductors to electrical equipment. Improper terminations can cause overheating, arcing, and failure of the connection. The NEC specifies the types of connectors and terminals that are suitable for use with different types of conductors. The connectors and terminals should be installed in accordance with the manufacturer's instructions and should be tightened to the specified torque. Regular inspection and maintenance of electrical connections are also important for preventing problems. Loose connections should be tightened, and corroded connections should be cleaned or replaced. It is also important to protect conductors from physical damage. Conductors should be installed in conduit or other protective raceways to prevent them from being damaged by abrasion, impact, or exposure to chemicals. In addition, conductors should be properly supported to prevent them from sagging or straining the connections. Grounding and bonding are essential safety measures in electrical systems. Grounding provides a path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and de-energize the circuit. Bonding connects all metallic parts of the electrical system together to create an equipotential plane, reducing the risk of electric shock. The NEC specifies the requirements for grounding and bonding electrical systems. The grounding system should include a grounding electrode, such as a ground rod or a metal water pipe that is connected to the earth. The grounding electrode conductor should be sized according to the NEC tables and should be connected to the service equipment and the grounding busbar in the panel board. The bonding system should include bonding jumpers that connect all metallic parts of the electrical system together, such as metal conduits, enclosures, and equipment frames. The bonding jumpers should be sized according to the NEC tables and should be securely connected to the metallic parts. Proper grounding and bonding are essential for protecting people from electric shock and preventing equipment damage. Regular inspection and testing of the grounding and bonding system are important for ensuring that it is functioning properly. Furthermore, surge protection devices, or SPDs, are often used to protect electrical equipment from voltage surges caused by lightning or other events. SPD divert surge currents away from sensitive equipment, preventing damage. The NEC recommends installing SPD at the service entrance and at sensitive electronic equipment. SPD should be selected based on the voltage and current rating of the electrical system. It is also important to properly ground the SPD to ensure that it functions effectively. In addition to the above considerations, it is important to be aware of the potential hazards associated with working with electricity. The electrical work should only be performed by qualified and experienced individuals who are familiar with safe work practices. Before starting any electrical work, it is essential to de-energize the circuit and verify that it is de-energized using a voltage tester. Rubber gloves and other personal protective equipment should be worn to protect against electric shock. The work area should be kept clean and dry to prevent slips and falls. Finally, it is crucial to remember that the information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and the local authority having jurisdiction or urge to ensure that the electrical installation complies with all applicable regulations and safety standards. When dealing with manufactured homes, specific requirements often apply due to their unique construction and installation methods. The National Electrical Code, or NEC, Article 550 provides specific guidelines for electrical systems in manufactured homes. One key aspect is the service entrance location. Typically, the service equipment is located on the exterior of the manufactured home or adjacent to it, often in a pedestal or similar enclosure. The wiring from the service equipment to the manufactured home's main panel must comply with NEC requirements for feeders or service conductors. Another consideration is the grounding and bonding of the manufactured home's electrical system. The metal frame of the manufactured home must be connected to the grounding electrode system, ensuring a safe path for fault currents. The bonding of metallic parts within the manufactured home is also critical to minimize voltage differences and prevent electric shock hazards. The NEC also addresses the wiring methods used within manufactured homes. Typically, NM cable or non-metallic sheath cable is permitted, but it must be properly supported and protected from physical damage. Flexible metal conduit, or FMC, is often used for connections to appliances and equipment that may be subject to movement. It is essential to carefully inspect the wiring and connections in a manufactured home to ensure that they are in good condition and comply with the NEC requirements. Over time, wiring can become damaged or connections can loosen, creating potential safety hazards. When making any electrical modifications or repairs to a manufactured home, it is crucial to obtain the necessary permits and inspections from the local authority having jurisdiction or urge. The HA will ensure that the work is performed safely and in accordance with the applicable electrical codes. Furthermore, it is essential to be aware of the potential hazards associated with working on electrical systems in manufactured homes. Manufactured homes often have limited space, which can make it difficult to access wiring and equipment. The wiring may also be concealed behind walls or ceilings, making it challenging to identify potential problems. It is crucial to exercise caution and take appropriate safety precautions when working on electrical systems in manufactured homes. This includes de-energizing the circuit before starting any work, wearing rubber gloves and other personal protective equipment, and keeping the work area clean and dry. Finally, it is crucial to remember that the information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and the local authority having jurisdiction or urge to ensure that the electrical installation complies with all applicable regulations and safety standards. The choice of conduit material for underground electrical service is critical, and while PVC is often used, it's essential to understand its limitations and potential alternatives, such as intermediate metal conduit, or IMC, and rigid metal conduit, or RMC. PVC conduit is lightweight, cost-effective, and resistant to corrosion, making it a popular choice for many underground applications. However, PVC conduit is not as strong as metal conduit and can be more susceptible to physical damage, especially in areas with heavy traffic or rocky soil. Additionally, PVC conduit is not permitted in all underground applications, such as those requiring a specific level of mechanical protection. Intermediate metal conduit, or IMC, is a galvanized steel conduit that is stronger and more durable than PVC conduit. IMC provides excellent protection against physical damage and is suitable for use in a wide range of underground applications. IMC is also easier to bend and thread than rigid metal conduit, or RMC, making it a more convenient choice for some installations. Rigid metal conduit, or RMC, is the heaviest and most durable type of metal conduit. RMC provides the highest level of protection against physical damage and is suitable for use in the most demanding underground applications. RMC is also more expensive and more difficult to install than PVC conduit or IMC. When selecting the appropriate conduit material for an underground electrical service, it is essential to consider the following factors. The type of soil in which the conduit will be buried. Rocky soil can damage PVC conduit, while corrosive soil can damage metal conduit. The amount of traffic that will be passing over the conduit. Areas with heavy traffic require stronger conduit materials, such as IMC or RMC. The depth at which the conduit will be buried. Deeper burial depths require stronger conduit materials to withstand the weight of the soil. The voltage of the electrical circuit that will be run through the conduit. Higher voltage circuits may require stronger conduit materials to provide adequate insulation and protection. The local electrical codes and regulations. Some jurisdictions may have specific requirements for the type of conduit that can be used in underground applications. In addition to the above considerations, it is also important to properly install the conduit to ensure its long-term performance. The conduit should be buried at the appropriate depth and should be supported at regular intervals to prevent sagging. The conduit should also be protected from physical damage during installation. Finally, it is crucial to remember that the information provided in this discussion is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and the local authority having jurisdiction, or OJ, to ensure that the electrical installation complies with all applicable regulations and safety standards. In the context of electrical installations, the authority having jurisdiction, or OJ, plays a vital role in ensuring safety and compliance with electrical codes and standards. The AHA is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The AHA can vary depending on the location and the type of electrical installation. In some cases, the AHA may be a local government agency, such as a building department or an electrical inspection department. In other cases, the AHA may be a state government agency or a federal government agency. The AHA has the authority to interpret and enforce the electrical codes and standards in their jurisdiction. They can also issue permits, conduct inspections, and approve electrical installations. It is essential to consult with the AHA before starting any electrical work to ensure that the installation complies with all applicable requirements. The AHA can provide guidance on the correct wiring methods, materials, and equipment to use. They can also answer questions about the electrical codes and standards. In addition to enforcing the electrical codes and standards, the AHA also plays a role in promoting electrical safety. They can provide educational materials and training programs to help electricians and homeowners understand the risks associated with electricity and how to prevent electrical accidents. The AHA can also investigate electrical accidents and take enforcement action against those who violate the electrical codes and standards. It is important to cooperate with the AHA and to follow their instructions. Failure to comply with the electrical codes and standards can result in fines, penalties, and even criminal charges. It can also put people at risk of electric shock, fire, and other electrical hazards. The National Electrical Code, or NEC, is a widely adopted electrical code in the United States. However, the NEC is not a law and it is not automatically enforced in all jurisdictions. Instead, the NEC must be adopted by the state or local government to become law. Once the NEC is adopted, the AHA is responsible for enforcing it. The AHA may also make amendments to the NEC to reflect local conditions or to address specific safety concerns. It is important to be aware of the amendments that have been made to the NEC in your jurisdiction. The AHA is a valuable resource for anyone who is involved in electrical work. They can provide guidance on the electrical codes and standards, help to ensure that electrical installations are safe and compliant, and promote electrical safety in the community. Furthermore, understanding the role of a qualified electrician is paramount in ensuring electrical safety and compliance. A qualified electrician is an individual who has the knowledge, skills, and experience to safely and effectively install, maintain, and repair electrical systems. Qualified electricians typically have completed a formal apprenticeship program or have received equivalent training and experience. They are also licensed by the state or local government. Licensing requirements for electricians vary depending on the jurisdiction. However, most jurisdictions require electricians to pass an examination to demonstrate their knowledge of the electrical codes and standards. Qualified electricians are familiar with the NEC and other applicable electrical codes and standards. They are also trained in safe work practices and are equipped with the tools and equipment necessary to perform electrical work safely. Hiring a qualified electrician is essential for any electrical work that involves the installation, modification, or repair of electrical systems. Qualified electricians can ensure that the work is performed safely and in accordance with the electrical codes and standards. They can also identify potential electrical hazards and recommend solutions to prevent electrical accidents. Attempting to perform electrical work without the proper knowledge, skills, and experience can be dangerous. It can also result in violations of the electrical codes and standards. In some cases, it can even lead to criminal charges. It is always best to hire a qualified electrician to perform electrical work. When hiring a qualified electrician, it is important to check their credentials and to verify that they are licensed by the state or local government. You should also ask for references and check their insurance coverage. A qualified electrician should be able to provide you with a written estimate of the cost of the work before starting the project. They should also be able to answer your questions about the electrical codes and standards and explain the work that they will be performing. Hiring a qualified electrician is an investment in your safety and the safety of your property. It can also help to ensure that your electrical system is reliable and efficient. Finally, remembering that this information serves as general guidance only and should not be considered a substitute for professional advice is crucial. Always consult with a qualified electrician and the local authority having jurisdiction or OJ to ensure that the electrical installation complies with all applicable regulations and safety standards.